just like with everything else, things can go wrong. Hypoproteinemia. Hypo means what? Not enough. It's low. So hypoproteinemia. Plasma proteins are not in a correct amount, usually due to extreme starvation. All right, something that we see in lesser developed countries. Liver or kidney disease, because the liver made 2 of the major categories of proteins. Okay, kidneys, their job, the filtration. Either one of those are going to affect the blood levels at a time of a severe burn. Why? Because everything is leaking out. It's the reason people die from severe burns. These materials just can't be replaced. That and the water of the blood can't be replaced. So that's when it becomes a pretty bad issue. In children that have a severe protein deficiency, this is known as kwashiorkor. And usually what happens when the child is weaned from the mother's milk, they're usually fed mostly, cereals or rice, all right? And they end up with the really thin arms and legs because they're not getting the proper fats, sugars, and proteins that are needed for proper cellular growth. And because of that, they end up, like with the really big abdomen, and that is ascites, and they usually die because of severe diarrhea that comes from this, that leads to the severe dehydration, and that's, really sad situation. So now, how is the blood that we have, how is it produced? In an adult, roughly 400 billion platelets, 1 to 200 billion red blood cells, and about 10 billion white blood cells per day are what's needed. Now, I'll take any of that with dollar signs behind it, okay? I will not argue, okay? I will gladly take it. Now, to get this, it's a process known, hemo, meaning blood, poiesis, production. The production of the blood, especially the formed elements. Those red blood cells, white blood cells, platelets. We have what's termed hemopoietic tissue. This is what produces the blood cells. Egg and sperm meet. Fertilization occurs. Cellular, 1, 2, 4 to 8, 16, all right? We form the yolk sac. The yolk sac produces the stem cells for the very first blood cells. They are going to colonize. What does it mean to colonize? Form a colony. How many different types did I say we had? 7. All right, so I'm going to need colonies that can give rise to these elements. So they colonize fetal bone marrow. We're going to find them in the liver, the spleen, and the thymus. In children, from itty bitty baby until they stop growing, well, puberty, okay, then it starts to begin to change. Almost all bone marrow is giving rise to the elements. Once we become an adult, that changes. Once we become an adult, only certain areas of the body are going to have the tissue producing the red blood cells. Do you know some of those areas that are going to be giving rise to it? But where is it found in an adult? In long bones. But in an adult, the femur, okay, our humerus, ribs, pelvis, some of the vertebrae. That's it, once we become an adult. When babies are born, liver stops it all together. Because the liver's got a lot more other stuff it's got to be doing. And that's not one of the things that it needs to be concerned about. The spleen stays involved. However, you can live without it. So, the production the red bone marrow gives rise to all of the elements. We have what's termed a PPSC, pluripotent. Stop and take that term apart. Pluri. Plural. Plural means what? More than one. Potent, strong, stem cell. What is a stem cell?
Differentiated cell?
It is a cell that is not identified.
It doesn't have a job.
It doesn't have a job. It hasn't given rise to something yet. Okay? How does it begin to give rise to something? How does a stem cell become a cell? Okay, if we have a need, how does the body communicate that need? What's another name for hormone? Chemical. Those cells receive a chemical. And that chemical sets off the series of reactions for it to turn into something. Why are they important? The stem cells.
Because usually they're fixing an issue, or they're recreating something.
Or they're giving rise to something. Right. They can be fixing something. They can be giving rise to something. Any of y'all keep up with stem cell research? Do you have a negative connotation that goes along with that term?
You're reading? Yes, I know.
Is that what the thing was mitochondrial and
switching the gene. That's not the stem cell.
However, mitochondria does have its own DNA.
Yeah.
And they've done research on the DNA of the mitochondria. And it's been very interesting what they have found. But mitochondria are part of our cells. So, stem cells. There's a lot of negative connotation with that. I hope after taking my class, you'll change your negativity and support stem cell research. Because think about this for a second. It's very important. If you were diagnosed today, or someone that you know or love was diagnosed today with something that's deadly, that you know is going to end up killing them or killing yourself, would you not be knocking on the doors of research labs and saying, what have you got going on? Or would you just accept it? Think about that. You don't have to answer me. Just think about it. And think about the controversy we have around it. So, pluripotent. That's going to be the hemopoietic blood production stem cell. A CFU, colony forming unit. Well, I got to make colonies, okay? A specialized stem cell that'll give rise to one class of my elements. Myeloid, the blood formed in the bone marrow. Lymphoid hemopoiesis, lymph, think about the white blood cells. This is blood formation in a lymph organ. For example, thymus, okay? Beyond infancy, this is only going to deal with lymphocytes. Don't worry, we're going to look at it. This is sort of what it looks like. For the red blood cells, they're trying to show us the red blood cell. This is my capillary wall, okay? Do you remember how we talked about, he talked about it being concave on each side? Therefore, it will be because it's both sides, to concave, okay? Really cool shape. It just looks like a donut, okay, to me. Just saying. Two functions. Carry oxygen from the lungs to the tissues. Pick up CO2 from tissues, bring to lungs. It doesn't care about anything else. That is it. Anything that affects your numbers of the red blood cells, you die within minutes. Because the tissues lose oxygen and boom, that sets off a whole series of reactions and it's done. All right? It doesn't take long for tissue to die when oxygen has been cut off. Think about someone who has a heart attack. Okay? When the blood flow is stopped to those particular cells, those cells die and never recover. So anytime blood flow is not sufficient to a tissue, it's no longer going to function. Brain not getting oxygen is bad. Yes. Asthma restricts the blood flow to all the tissues. Yes. They're termed to be disc-shaped. Not very big. I don't care if you know those numbers or not. I'll never ask you those numbers. During development, I think this is so cute. Okay? The red blood cell, it starts out as an immature cell and it has to become mature. All right? As it matures, it literally takes its organelles and spits them out. Nucleus gone, all those other organelles out. Because the only thing it wants to do, is have that hemoglobin so that it can do the oxygen. Because it knows it's not going to live very long, okay? That it's only going to have about 120-day lifespan. They don't have mitochondria, so to get their energy, the only thing they can do is anaerobic fermentation. As they're mature, the nucleus and therefore DNA are gone. So what does that tell me about the production of the hemoglobin when it's immature? When it's immature and it has the nucleus, it has the organelles, it has the DNA, what's the job? What does it need? Remember, the one thing it can produce is a protein. What protein is getting produced at the time it has all of its organelles? My hemoglobin. So when it has its little few days, and I mean few, okay, of being immature, it is so busy making hemoglobin, it's like nothing else exists. And then it says, oh, I got enough, let me move out here. And then it'll flow around in the blood and it'll begin to mature a little bit more, spit out its organelles, and then boom, it's ready to work. Cool. Think about it. So, take a break. Be back at 9:30.